Now for example 3, you're going to need to change the equations in your workbook. Let's change the examples to part A, make that the square root of 9x. And then part B, make that the square root of 4x plus 16 plus 7. Those will just make it easier, nicer numbers to deal with. So example 3 is talking about rewriting radical functions to identify the transformations. And you might look at this and be like, oh, I can see the transformation already. So be careful, because remember earlier I said make sure whenever you're looking for transformations that the number, the coefficient from the x needs to be a 1. So just as a reminder, here's the general form that we want. We need this form, a times some kind of root, I'll call it the nth root, of x minus h under the radical plus k. We need it in this form, and the coefficient needs to be a 1. If it's not a 1, we need to make it happen. So we're going to make it happen by factoring. All those algebra skills you have with factoring are going to be put to use. So on example A, I've got that 9x. Now this is just one term, so actually let's do example B first, and then we'll come back to example A. So let me just do this. Well, this is going to be your example B. So again, make sure you change example B to look like this. All right, so we're going to make that coefficient a 1 by factoring it out. So what we're going to do is we're going to factor out a 4. So under the radical only, so I'm going to factor 4 out from 4x and a factor 4 out from 16. So that now my equation looks like h of x equals the square root of 4 times x plus 4, and then plus 7 on the outside. And then remember how I said maybe it was last lesson or the lesson before, as long as you are multiplying under the radical, you can write it as separate radicals. Well, I've got multiplication happening between 4 and the parentheses, so I can write h of x as the square root of 4 times the square root of x plus 4, because there's multiplication occurring between the 4 and the x plus 4, and then plus 7 on the outside. So now I can take the square root of 4. H of x equals 2 times the square root of x plus 4, and then plus the 7 on the outside. And now look, the coefficient on the x is a 1, and now it's in a form where I can identify all the transformations. So I can see that plus 4 is going to signify a shift of 4 units to the left. The multiplying by 2 is a vertical stretch of 2. And then the plus 7 is a vertical shift up 7 units. So now let's go up back to example A. There's only one term under here, so I am going to factor out that 9, or I can split this up because the only thing that's happening between the 9 and the x is multiplication. So I'll rewrite g of x as the square root of 9 times the square root of x. And the square root of 9 is 3. So g of x equals 3 times the square root of x. So what is the transformation involved? It's just that 3 in front, which is a vertical stretch by a factor of 3. And then here's the last example we have right now, example 4. I believe this is the last example. Yeah, last example for today. Example 4. So this is where they give you a graph, and then you are going to try to come up with the equation. Now, I will say your picture on B, if you look at your workbook, the picture that you're looking at right now is not the one that you see on your workbook. So we're just going to go ahead and mark off part B. Okay, So let's talk about how to write the equation when you have the graph. First of all, the first thing you need to do is you need to figure out what kind of function it is. So number one, is this going to be a square root or a cube root function? Well, it'll be a square root if it just has, like if it's half a parabola. It'll be a cube root if it looks more like this sideways S shape or a stretched out S. So it looks like for us, we have a square root function. Check. So I'm going to circle this. That's what I have. Square root. So that's what I'm going to start off with. I'm going to start off with y equals the square root of x. Second part is to look to see if there are any horizontal, I'm just going to draw a horizontal line, or vertical shifts. Now, it's handy if you kind of sketch the parent function as well. 4, 2, 3, 4, 2. Oh, this is not going by ones. Hold on. Let me sketch the parent function. All right, the parent function is on there. There's a point at 1, 1, 4, 2, and 9, 3. I didn't realize the scale was different on the horizontal and vertical axis. So, but we're all good now. Okay, so have there been any horizontal or vertical shifts? Well, I can see, I like to look at the starting point here and the starting point there. Looks like that got shifted to the left 5 and down 4. So left 5, down 4. So I'm going to add those to my equation. So if I want to go left 5, square root of x plus 5, and then down 4 would be minus 4. Okay, let me just erase. Oh, no. Then the third thing you're going to do is you're going to check for vertical shifts, vertical stretch or compression. Stretch or compression. And the way that I like to do that is I like to look at the parent function from the very first point to the next one and kind of count kind of the slope, even though this is a curve. We're not really looking at a slope, but from the first point to the second point, I have to go to the right one and up one and see if the same thing happens. If something different happens, then that would be your stretch or compression. So from 5, -5, -4, if I go to the right one and up one, then I do land on that curve. So it looks like there hasn't been a vertical stretch or compression. So it looks like my equation is going to be y equals x plus the square root of x plus 5 and then minus 4. Then if you want to double check, I would graph my equation that I came up with in Desmos and then see if it matches the one that's on the paper.